Hi, so I'm going to take you through this machine learning project I did um, in Python. So the case study is that a startup launched a marketing campaign across media channels, various channels to help increase brand awareness and click-through rate considerations towards students' enrollment. However, based on historic data, cost spent by companies higher than the return on ad spend. So our goal is to build a machine learning model to predict return on ad spend to help the marketing team inform decisions on how to allocate marketing budget. So we start with we import the necessary Python libraries that we need for the process. And secondly, we load the data because we have the CSV file that contains the information on age, gender, interest, impression, click, spend, total conversion on the information on the ads, the digital ads. Then the next thing is to see if this really loaded. Start with exploratory data analysis. So we check data frame is called DF. So we use df.head 5 to check for the top 5, for the bottom 5. Then we can also check for the top and bottom 5 to make sure everything is well loaded. And we can see we have 100 rows and 8 columns. So this also is seen in the next line 49, where it shows number of observations, data points, data types, and any missing data, if any. So we can see already without even running the code for missing data, that there isn't any missing data as it is. So they're all 100 and 8 columns. So just do a bit of exploratory analysis to just figure out how our data is. So we check for missing values now with df is null, and count also with df dot is null bracket dot sum to see if there's a summation of any missing values, and you can see that there's none. So I decided to make it easier for me to put them to lowercase, as well as just cleaning up the data type, and also to shorten the names for ease of the tables looking neater. So I use the rename data frame method to rename the columns, and then check that to see that it's working. Also, we also check columns that contains only numerical values as well, and dropped columns that had, so this is just cleaning up data, dropped columns that had um redundant, like column ID. We're not going to use it for analysis, so there's no point actually having it. We also checked for duplicates values, there are none. And so we now see the output distributed data statistics for the data sets. So we can see the count, the mean, the standard deviation, the max, the minimum, the 25th percentile, 50th percentile, 75%. So we can now went ahead to do some statistics analysis on the data sets to see the mean, the total sum of some of the columns, just to see how that plays out. Then we first of all now decided to find correlation between numeric variables. So we can see already from this one that those that have the value of 1, you can see the stronger correlations are clicks and spend, because it's 0.9, and which is closest to 1. So we're already beginning to see some correlation and how this is going to affect analysis at the end of the day. So to just visualize the trend, we've done some pre-analysis. So we decided to just visualize the trends to see how this visually how they apply. So we tried to do a box plot to visualize and identify outliers, looking at age as against clicks. So we can see that people aged 34, this is a box plot. We can see that people aged 30 to 34 had the most spend, uh, and then there's more likelihood to get more enrollments on people uh 30 to 34 and 25 and to 29. So we're already beginning also to see some in terms of age, the target audience to get to. So if we can market towards the other groups that are not coming up, then we can ask our questions why they are not coming up. So these are some insights we're already beginning to gather. So we can also we also plotted a histogram. I also plotted a histogram to show clicks against impressions, and you can see what it looks like. Um, this also still shows that there's a strong relationship between clicks and spend. So when we look at a bar chart using categorical variable to show age distribution, we see that the the highest group is actually 20 to 24, but like we saw before, they are not the ones spending the most. The spending is not on them. And so we have to look at how we can refocus and spend more of this marketing tactics on this age group. So that's one takeaway, to target the ages of 20 to 24, since they're the highest demography that we have. So in terms of gender, we have more male than female. Then we look at correlation, looking at scatter plots between clicks and spend. So this just reinforces what we've already seen before, that there's a strong positive correlation between clicks and spend. And so the more you spend, the more clicks there are, as well as impression and clicks. There is a correlation between impression and clicks as well. So we have these are just visualizations of the different how the different variables interact. So we also use heat map to check the relationship between two variables, and we can also see that coming out here, impression, clicks, and spend, there's a strong relationship between them. So we'll move on to feature engineering. In feature engineering, we convert the categorical variables to numerical variables using hot code encoding. So we look at one hot encoding, then we look at the counts. We did that for age, and as well as did that for the gender as well, which is also a categorical variable to become a numeric variable. So when we do this, we can now see what our data temp is. Everything is now numeric in line 96, the output of 96. So feature engineering also includes creating new features. Remember that we are looking at return on ad spend, click-through rate, and cost per click. So these are new features we want to create, and we can calculate them with the existing data that we have. So we calculated click-through rate by dividing clicks by impression multiplied by 100. The click per cost per click, we divided spent by clicks, and return on advert spent, conversion divided by spent. So when we did this, we created a new table in line 100 the code 100, which has an output of the whole table. So what we did next was to rename some of the, just to clean up the table again, just to make it look smoother, and then select only the features that reflect consumer engagement, the KPI matrices that we're looking for, like the CTR, the CPC, the return on advertisement, the conversion, impressions, spent, and clicks. These are the ones. So things like gender, age are not really KPI matrices. So we drop them at this point just to stop, not to carry the excess columns around. So we scale the values because some values can become small. So we imported standard scalar, and then also with that, we also use this new table to create a heat map to see the correlation between the variables. And you can see the insights. You can see that the clicks are totally dependent on spend. So the it's so for us to increase conversion rates, we need to increase marketing budget because there's a strong relationship between market spend and conversion. And the higher the budget, the higher the conversion. So they need to actually spend more money to actually get that conversion that will lead to more clicks. So as you can see, that clicks is dependent on impression spent and clicks. So we have to get that we've seen that correlation. So there are no missing values to treat. Also in feature engineering, there are no missing values to treat before building the machine learning. So we'll move on from there. So for the machine learning, we are using random forest algorithm. For that, we import the random forest regressor and then define the predictor and input factors. We use the x-axis as one, and then the y-axis as return on adverse, and all the columns excluding the predictor column. That's everything else excluding the return on adverse spent, and y-axis on the becomes the return on adverse spent. So we now, of course, train and test the model. So we do that and move on from that to so more or less we train using random forests, using 1,000 trees, and then now we test the model. And when we do that, we can actually now have a predicted values and an actual values, and which can be visualized. So after that, we can now validate our model using matrices. So we import matrices as a library, and then we check out for the absolute mean, absolute error. These are means to validate, mean squared error, mean squared root mean squared error, and R2. So these all gives us insights as to the predictive, the accuracy, and how the errors we have in this model. So the R2 gives the one for accuracy, and it stands at 74%, which is not bad, which is actually high. So that means that the model did a decent job of predicting the return on adverse spend. So that's just a bit about the Python project I did using machine learning, by building machine learning model. Thank you very much.